All right, in this lesson 3.02b, what we are doing is we're going to take this algebraic expression, so all of this here, and we want to write as a multiplication. That's why I put the two parentheses. And what you write in the first parenthesis is going to be the monomial GCF, one term. And what goes in the second parenthesis is the algebraic expression that is left over. Now we use the box method to multiply a monomial by an algebraic expression. So that's what I'm going to do. I'm going to use the box method but backwards. I'm going to figure out the side. So what goes inside the box is the expression, okay, what I highlighted in purple. And what I want to do is I want to find the GCF that goes here. And I also want to find out my expression that goes on the top here. Okay, so we're using the box method backwards. So let me write the algebraic expression that I was given. So I'm going to put here 33x to the third, and here I put 79x. And I want to find the size of the boxes, see the left side and the tops. Because if you remember from a previous lesson, we multiply the size of the box to get what is inside the box, okay? Now, how do we find the GCF, what is highlighted in yellow? Well, what we're gonna do, like we did in yesterday's class, we're gonna find the GCF of 33 and 79, okay? And to find that, you're gonna find the factors of 33, so 1, 3, 11, and 33. You're gonna find the factors of 79, there's only two, 1 and 79. And what is the largest factor in common? You can see is 1, so that goes here, okay? The next thing I'm gonna do is I'm gonna find the variables in common, and you can see I have two x's here. So I'm gonna expand each of these letters. I wanna use red, let me use black. So x to the third, I'm gonna expand that, so x times x times x, and the other x is only 1x. And how many x's we have in common? You can see we only have in common 1x, okay? So that's what goes there, and that's my GCF. Now, when one is multiplying a letter, we do not write 1. So let me take this out. We just say x. What is on the side of the box there, my GCF, that's what goes in here in the first parenthesis. So I'm going to put in there x. Now I'm going to find what goes in the second parentheses, what goes here, and what goes there is what is on the top of the box. Okay, how do we find the top of the box? We're going to take the first box that has 33x to the third. I'm going to divide it by 1x. Okay, I know I erased it, but I'm going to keep it here so you see the division. Okay, 33 divided by 1 is 33. And when you divide letters that are the same, you subtract the exponent. The x on the bottom has an exponent 1. So 3 minus 1, that will be x squared. And that's what I'm going to put up here, 33x squared. Now I'm going to take the second second box, what is inside, 79x, I'm going to divide it by 1x. 79 divided by 1 is 79. And again, when you see an x by itself, the exponent is 1, or any letter by itself, the exponent is 1. 1 minus 1, it should be x to the 0. But when the exponent is 0, basically it means you're not going to write the letter, the variable. So 79 is positive. And what I wrote on the top of the box, that's what goes right there. And my two parentheses is my answer. Okay? And that's how you do problem number 1. Let's go to the next one. Okay, here is problem number 2. Okay, they gave us an algebraic expression. So all of this is an algebraic expression. I want to write as a multiplication. I'm going to take that expression and put it inside the two boxes here. And here's how you do it. I'm going to put the 6x to the third power here, the negative 24x here, okay? I want to find the side of the boxes, so when I multiply, I get what is inside. We're going to start with the GCF, Okay, and then you're going to find the GCF of the numbers. That's step number 1, 6 and 24. Again, if I do the factors of 6, here are the factors of 6. You're going to have to remember your times table. Here are the factors of 24. Okay, I remember my times table pretty good. If you have trouble, use the calculator. Okay, and I hope you notice that the largest number, the largest factor in common is 6. So my GCF of 6 and 24 is 6. I put it there in the yellow section. Now we're going to do the same thing with the letters. I have here x to the third, and I have an x. I'm going to expand them. So x to the third is x times x times x. 1x is just an x. Okay, and I hope you notice we have in common 1x, and that's what goes here. And that's what goes in here in the first parenthesis. Now I'm going to find the top of the box. Okay. And how do we do that? We're going to take the 6x to the third power inside the first box, and I'm going to divide it by the GCF. 6 divided by 6, 1. And when you divide letters that are the same, you subtract the exponent. Keep the letter, subtract the exponent. 3, subtract, this x has exponent 1, so that's how I got x squared. However, when you have a 1 multiplying a letter, we do not write the 1, so I'm going to put here only x squared. Now I'm going to do the same thing for the second box, the top. So I'm going to take what is inside and I'm going to divide it by the GCF. Negative 24 divided by 6 is negative 4. And when you subtract the exponent of these x's, you get x to the 0. Okay, but like I said in the previous problem, when the exponent is 0, we do not write the x. That's what I'm going to put here, minus 4. And that's what goes in the second box here. And we did problem number 2, a similar one, of course. Let's go to the next one. All right, here's problem number 3. Okay, a similar one. They gave us this algebraic expression, so I'm going to take all of this, and I want to write as a multiplication. That's why you see the 2 parentheses. I'm going to take my algebraic expression. I'm going to put it inside the box here. So that's what I'm going to put in here, negative 55, x to the 5th, y to the 5th, and then here negative 66, x to the 3rd, y to the 4th. Okay, and I'm going to find the GCF, which is the yellow section here. How do I do that? I'm going to do the GCF of the numbers of 55 and 66. Okay, now I'm going to start doing the GCF of numbers mentally. I'm not going to write down all the factors because that's time consuming. So using your times table, the largest number that you can multiply, that will give you 55 and 66 is 11. And that's the number that goes here. Okay. And now I'm going to find the GCF of the letters. In the previous problems, I expanded the letters. So for example, x to the 5th, I will have written x times x times x times x times x. And x to the 3rd, I will write x times x times x. And then I will count how many x's we have in common. However, there's a shortcut, and that's what I'm going to share with you. Okay, look at the x's. We have that x in common. And the first one has exponent 5, the other one has exponent 3. Always choose the letter in common with the smallest exponent, and my smallest exponent here is 3. Okay, and look, I got the GCF of the x's. I'm going to do the same thing with the y's. Okay, the y's are in common. I'm going to choose the smallest exponent, and the smallest exponent is y to the 4th. Okay, this is just a shortcut to speed up the process. Now I'm going to find the tops. Okay, and by the way, this is my GCF. Let me write in the first parenthesis, 11, x to the 3rd, y to the 4th. That's my GCF. Now I'm going to find the tops. How do we find the tops? We're going to take the first box, negative 50, what is inside, negative 55, x to the 5th, y to the 5th. I'm going to divide it by my GCF, 11x to the 3rd, y to the 4th. Using a calculator, negative 55 divided by 11 is negative 5. When you divide the x's, keep the x, subtract the exponent. I get 2. Do the same thing with the y's. Keep the y, subtract the exponent. The exponent is 1. However, when the exponent is 1, remember, we do not write the exponent. So what I'm going to put on the top of this box is negative 5x squared y. Let's do the same thing for the second box. What is inside? So I'm going to take negative 66 x to the third, y to the fourth, and I'm going to divide it by the 11 x to the third, y to the fourth. Negative 66 divided by 11, negative 6. When you subtract the exponent of the x's, you get 0. The same thing happened with the y's. But when I write my answer on the top of the box, when the exponent is 0, I'm not going to write the letters. I'm going to put minus 6. And that's what goes right here in the second parenthesis. The two parentheses is my answer in the box. Let's go to number 4. So here is question number 4. Okay, a similar one again. I'm going to take this algebraic expression and I want to write it as a multiplication. So I'm going to write the algebraic expression inside the box. Okay, so I'm going to put here negative 36y to the second. And here I'm going to put plus 12y to the third. I want to find the side of the boxes. So when I multiply, I get what is inside the boxes. That's what the two parentheses is saying. How do we start this? We're going to start with a GCF of 36 and 12. Okay. Again, using mental math, times table, largest number divide 36 and that can multiply. What is the largest number that when you multiply will give you 36 and 12? That will be 12. That's what I'm going to put here. And then using the trick that I show you with the letters, let's find the GCF of the letters. Okay, I have the y in common. I need to pick one of them. Always pick the letter in common with the smallest exponent. In this case is y squared. And that's what I'm going to write in the first parentheses. In the second parentheses, the way we figure out, we're going to find the tops. And I'm going to take the what is inside the first box, negative 36y squared. I'm going to divide it by the GCF, 12y squared. Calculator or mental math, negative 36 divided by 12 is negative 3. When you subtract the exponents of the y's, you get 0. But remember, when the exponent is 0, we do not write the letters. I'm just going to put negative 3. I'm going to take the second box, what is inside, 12y to the third power, and I'm going to divide it by 12. 12y to the third power. I'm going to divide it by 12y squared. 12 divided by 12 is 1. When you subtract the exponents of the y, you get 1. But remember, when the exponent is 1, we do not write it. And when the number multiplying the letter is a 1, we also don't write it. I'm only going to put the plus sign, and that's what goes in the second box. And my answer is the two parentheses. Okay, because we're writing these algebraic expressions as multiplication. Let's go to the next one. All right, and the next one, what I'm going to do is, again, same thing. I'm going to take this algebraic expression. I'm going to write as a multiplication. I'm going to put the expression inside the box. Okay, so I'm going to write here 17x to the 4th power. Here I'm going to write negative 20. Okay, I want to find the size of the boxes. So when I multiply, I get what is inside the box. That's why we have those two parentheses. We're going to find the GCF first, okay? And here I'm going to write down all the factors of the two numbers that I have. So I'm going to find the GCF of 17 and 20 because I want you to notice the following. Okay. All the factors of 17, 1 and 17. There's nothing else that will make 17 when you multiply. Same thing with 20. 1, 2, 4, 5, 10, and 20. Those are all the factors of 20. And if you notice, the only factor in common here is 1. That's what I'm going to put here. Okay, that's my GCF. When I do the letters, if you notice, I do not have an X in common. There's no X within minus 20. So the GCF has no letter because there's no letter in common. So I'm going to put a 1 here only. And then what do I write on the top of each box? What I'm going to do is take what is inside of the first box, 17x to the 4th power, and I'm going to divide it by 1. And when you divide by 1, 17 by 1, you get 17. And you still have the same letter. So that's what goes on the top. Same thing is going to happen when you take negative 20. You divide it by 1. You're going to get negative 20. Okay, and that's what goes in the second box. And here's how you write that algebraic expression as a multiplication. Okay, let's go to problem number 6 now. Here's problem number 6. Again, a similar one. I'm going to take this algebraic expression, write it as a multiplication. So the way I'm going to do that, I'm going to use the box method backwards. I'm going to write the algebraic expression inside here. So 10x to the 3rd power goes here. The plus 20 goes here. I want to find the GCF, which is the yellow section. Okay. And the way I do that is I'm going to find the GCF of the numbers, the coefficient 10 and 20. I'm not going to write down all the factors. I'm going to do this mentally. The largest number that you can multiply that will make 10 and 20 is 10. So that's my GCF here. And the next thing I need to do the GCF of the letters. Instead of expanding them like I did at the beginning of this video, I'm going to use the trick. I'm going to check if I have the letter X in common in both terms. And you can see the 20 doesn't have an X. So that means that X is not in common. That's what the letter C stands for, common. We do not have the X in common. So my GCF here is going to be only 10. Now, how do we find the parentheses in blue? I'm going to find the tops of the boxes. So I'm going to take what is inside the first box, 10x to the 3rd. I'm going to divide it by 10, the GCF. 10 divided by 10 is 1. We keep the x. But when you write your answer, I'm not going to include the 1 that is multiplying the letter. I'm just going to write x to the 3rd. Then I'm going to take the second box, what is inside. I'm going to divide by 10. And 20 divided by 10 is 2. So I'm going to write here plus 2. So there goes what goes inside the second parenthesis. Okay. Let's go problem number 7. Yes. Here's problem number 7. Again, a similar one. So I'm going to take this algebraic expression. I want to write it as a multiplication. So I'm going to take the algebraic expression, put it inside the box because I'm using the box method backwards. So I'm going to write here 4x to the 4th power, y to the 3rd. Here goes the plus 10xy squared. I want to find the side of the boxes that will give me what is inside. How do you do that? We're going to find the GCF first. So we're going to find the GCF of the numbers, the big numbers, the coefficients. So GCF of 4 and 10. Now, I'm going to do this mentally. I know my times table. If you have trouble, you're going to have to use your calculator, okay? Largest number that when you multiply makes 4 and 10. That will be 2. That's why I'm going to put 2 here. And now I'm going to use the trick of the letters to find the GCF of the letters. I'm going to check if I have the letter X in common in each term, and I do. And I'm going to pick the X with the smallest exponent because the X is in common. Pick always the letter with the smallest exponent. This has exponent 4, this has exponent 1. So my GCF of the x's is just x because x to the first power has the smallest exponent. I'm going to do the same thing with the y's. I'm going to check I have the y in common. I do. And I'm going to pick the smallest exponent of the y's. That will be y squared. And look, I got my GCF. That's what I'm going to write inside here. Now I'm going to find the top of the boxes. How do we do that? We're going to take what is inside the first box, and I'm going to divide it by the GCF. Let's do the division. 4 divided by 2, 2. When you're dividing the x's, keep the x, subtract the exponent. This has exponent 1, okay? 4 minus 1, 3. Let's do the same thing with the y's. 3 minus 2, 1. But when you write your answer and the exponent is 1, we do not write the exponent 1. So I will write 2x to the third power y. I'm going to do the same thing. I'm going to find the top of the second box doing the same thing. So 10xy squared over 2xy squared. 10 divided by 2 is 5. These x's have exponent 1. 1 minus 1 is 0. And the y's, when I subtract the exponent, I also get 0. But when you write your final answer, okay, when the exponent is 0, do not write the letters. Just don't write the letters. So my answer here is plus 5. And that's what I write in the second parentheses up here in blue. And that's my answer for problem like number 7. Let's do the last one. So here's problem number 8, again a similar one. I'm gonna take this algebraic expression and I want to write it as a multiplication. I'm gonna use the box method backwards. So I'm gonna take the algebraic expression, write it inside the box. So let me put here 20x to the 4th and here negative 28x. And I want to find the size of the boxes so I can write it, because when you multiply the side of the boxes is what you get, what is inside the boxes. So I want to find the size of the boxes so I can write as a multiplication. Okay, how are we going to do that? We're going to start with a GCF. We're going to find the GCF of the coefficient, the big numbers, 20 and 28. Okay, using mental math, the largest number that you can multiply that makes 20 and 28 is going to be 4. So that's what goes here. And to find the GCF of the letters, I'm going to make sure that I have the letter X in common in each term. So I do. And we're going to pick the X with the smallest exponent. The first one is X to the 4th power. The other one is X to the 1st power. So the smallest exponent is X to the 1st power. But again, I'm not going to write the exponent 1. And look, I got my GCF. Now let's find the top of the boxes. Okay, so we're going to take what is inside the first box, 20x to the 4th power. I'm going to divide it by 4x. Divide 20 divided by 4. Oh, that's 5. Subtract the exponent of the x's. This exponent, the exponent of the x on the bottom is 1. So 4 minus 1 is 3. Look, I got the top of my first box. Let's do the same thing in the second box. Negative 28x. We're going to divide it by 4x, the GCF. Negative 28 divided by 4, negative 7. When we subtract the exponent of the x's, so they are 1s. 1 minus 1 is x to the 0. But again, when the exponent is 0, we do not write the x. I'm just going to put minus 7. And look at my answer. Okay, there we go. And that's how you do this lesson.